Hello, Integrated Math 3 and Integrated Math 3 Plus. Welcome to lesson 11-3, where we're going to continue solving quadratic inequalities. Now, before we get into inequalities, we were doing this last lesson, right? We had x times 15 minus x, and we said it was greater than or equal to 50. And we, did a really great job modeling the situation. And we used graphs to find that our solution was 5 is less than or equal to x is less than or equal to 10. The x had to be greater than 5, but it also had to be less than 10 or equal to either one in order to give us a proper solution, in order to be greater than 50. And we used the graph, and we were like, oh, this is what we want, and so it's got to be in between here somewhere. The only thing is, we also mentioned last time that graphs are only great if you have the graphing technology in front of you to make that happen. So clearly we need some sort of analytic way of doing this. That just means we need a way to be able to work out the answer. So before we worry about an inequality, let's just bring it back to this. Let's say that we want x times 15 minus x to equal 50. You guys have learned a lot of different techniques for solving this. You've learned about completing the square, you've learned about the quadratic formula, you've learned about factoring, and I'm not gonna lie, factoring is often the easiest way to go. So we've learned all these techniques, these analytic techniques. You didn't know they were called analytic, but they are. You can also most think of them as algebraic. But we've learned a lot of different techniques for solving these. Now, factoring is usually the fastest. If it'll factor, it's definitely the fastest way to go. So what I would like you to do is I would like you to solve this by factoring. It does mean you may need to multiply first. It does mean you're going to need to set it equal to 0 and then factor it and work your way through it. But this is question number 1 on student activity sheet number 3. So go ahead and hit pause to work your way through this and then hit play when you're ready to check your work. All right, so let's see what we got here. So first I multiplied through x times 15 is 15x, x times a negative x is negative x squared. I subtracted 50 from both sides, and then I realized I had a little issue because I didn't want a negative out front. So I multiplied both sides by a negative 1. Multiplied by a negative, it became positive. Multiplied by a negative, it became negative. Multiplied by a negative, it became positive. And suddenly that's way easier to work with. And I went ahead and factored it out. And that means that my solutions are x equals 5 and x equals 10. So here's the deal. You can use a similar technique for inequalities. Now, you may get a little stuck at some point because, of course, it's not equal to, right? It's greater than or equal to, and so it's going to be a little tricky. There are a few little tricks here. But if you go down to question number 2, we are going to apply a similar technique to help us solve our inequalities. You ready? So start off doing what you did before. Let's start off by doing exactly what we did before. So I'm going to multiply through my x. So that means I get 15x minus x squared. And then I'm going to subtract 50 from both sides. Yay. So we'll subtract 50 from both sides. Boom. It's got a 0. Rearranged it a little bit so I had my x squared out front. Now, there's a little trick on this. Remember how we didn't want that to be negative? We wanted it to be positive. So I'm going to multiply both sides by a negative 1. But do you remember the old trick with inequalities? When you multiply both sides by a negative, you have to flip your inequality. So I'm going to multiply both sides by a negative, which is going to flip my inequality. Instead of a greater than or equal to, it becomes a less than or equal to. That's a really critical step. Remembering that when you multiply both sides by a negative, it reverses the direction of your inequality sign. And then I'm just going to factor it like we did last time. So here we go. Question number 2. Yay. Only it looks different this time. Last time it was easy because we were like, oh, it equals 0. Well, so 5 would have to be 0 and 10 would have to be 0. But this one's a little different because what about that less than symbol? So we have to do a little extra with these guys, okay? Just a little extra. So we're going to come over to question number 3, which right now looks really, really scary, but I'm going to walk you through. I'm going to explain it. I basically have 2 factors here. And what we're going to do is we're going to see if we get negatives or positives, right? Because we're looking at less than or equal to 0. So fine, if I plug in, say, 0, if I plug in a 0, 0 minus 5 is going to give me a negative answer. If I plug in a 0 here, 0 minus 10 will also give me a negative answer. But notice how they're being multiplied together. So that means that negative times a negative will give me a positive. The only thing is we want it to be less than or equal to 0, not greater than. So no, 0 cannot be a solution. I have it here again with 5. If I plug in a 5, 5 minus 5 is 0. If I plug in a 5, 5 minus 10 is still a negative. If I plug in a 5 then, so that means if I do 0 times a negative, 0 times a negative gives me 0, and we said 0 was okay, less than or equal to was fine. If I plug in a 6, 6 minus 5 gives me a positive answer. 6 minus 10 gives me a negative answer. And a positive times a negative will give me a negative. Sure enough, a negative would be less than or equal to 0. So yes, 6 is a solution. So 0 is no good, 5 is good, 6 is good. Notice I'm not looking for exact values. I just want to say, hey, if I plug in a 10, will that be positive or negative? If I plug in a 10, will that be positive or negative? When I multiply them together, what do I get? And then does that work for our inequality? So go ahead and hit pause to work your way through this table on question number 3, and then hit play when you're ready to check your work. All right, guys, if I plug in a 4, that's negative. If I plug in a 4, that's also a negative. And a negative times a negative gives me a positive, which would be greater than 0, not less than 0. So I'm going to say no good. No bueno. If I come over here to question number 9, if I plug in a 9, that becomes positive. If I plug in a 9, that's still negative. Positive times a negative gives me a negative. Yep, less than 0. That's a good one then. If I plug in a 10, 10 minus 5 will give me a positive. Plug in a 10, 10 minus 10 gives me 0. And anything times 0 will give me 0. And we said 0 was okay, less than or equal to, so 0 is all right. Let's see then, if I plug in a 12, 12 minus 5 gives me a positive. 12 minus 10 gives me a positive. Positive times a positive is a positive. Ooh, but a positive would be greater than 0, so that's no good. And if I plug in a 15, 15 minus 5 is positive. 15 minus 10 is positive. Positive times a positive is a positive, and that would make it greater than 0, not less than 0. So we're going to say that's no good. All right, given this pattern that you've seen, maybe you've noticed some patterns emerging here. What I would like you to do is kind of use these patterns that we're noticing, where it was good, where it was not good. I would like you to go ahead and fill in question number 4. You have a lovely table here on question number 4. Plug in, fill in your blanks with either negative, 0, or positive. That's all I want you to do. And you can use the earlier table to help you figure that out. So go ahead and hit pause to fill in your table, and then hit play when you're ready to check your work. All right, so I noticed whenever I plugged in a number that was less than 5, that this was negative and this was negative, and multiply them together, it gives me a positive. I noticed when I plugged in a 5 exactly that this became 0 and this was still negative. And 0 times anything is, well, 0. When I plugged in a number on that last table that was between 5 and 10, like we plugged in a 6, we plugged in a 9, when I plugged in a number between 5 and 10, I realized that I got a positive for this guy and I got a negative for this guy. And a positive times a negative gives me a negative. When I plugged in a 10 exactly, my x minus 5 was positive, but my x minus 10 is 0, and 0 times anything is, well, 0. And then when we plugged in numbers bigger than 10, like we plugged in a 12, we plugged in a 15, when I plugged in numbers bigger than 10, then both of these guys were positive, and positive times a positive gives me a positive answer. So this is going to lead us toward the solution of the inequality. This feels like a lot of work, so we're gonna change it up a little bit. We are going to make something called a sign chart or a sign table, typically called a sign chart. And I'm going to show you how this works. This is really cool because it can actually help us solve our inequality without having to have a graph. Now, I am going to start off with a graph just to show you. So we graphed x minus 5 times x minus 10, and you get this lovely graph. And of course, we know it hits at 5 and at 10. Like we knew that was going to happen because when we set it equal to 0, that was what happened to us. So what I'm going to do is I'm going to take that number line over, and I'm just going to focus on the 5 and the 10. So I'm just going to focus on 5 and 10, because I know if I plug in a 5, I get 0. If I plug in a 10, I get 0. And what we're now going to do is we're going to construct a sign chart to help us solve our inequality. So this means I'm going to pick a number between 0 and 5 and plug it in, see who's positive, who's negative, and what we end up with. And then I'm going to do it again over here. Pick a number between 5 and 10, plug them in, positive or negative, and I'm just going to put plus and minus. I'm super lazy. I'm not even going to use the words. And then I'm going to plug in a number greater than 10 into each of these, see if it's positive or negative, and if I multiply them together, what that gives me. I'm going to give you a moment to see if you can play with this a little bit and figure it out. So go ahead and hit pause, put in your little pluses and minuses, and then hit play when you're ready to check your work. All right, so I'm going to plug in something between 0 and 5. Let's say a number like 3. So if I plug in a 3, that would be negative. This guy would also be negative. Negative times a negative gives me a big fat positive. Yay. If I fill out the next little chunk, something between 5 and 10, so maybe, I don't know, like a 7. 7 sounds good. If I plug in a 7, that's positive. If I plug in a 7, that's still negative. Positive times a negative gives me a negative. And then I'm going to plug in a number bigger than 12, bigger than 10, like 12 or something like that. If I plug in a 12, that's positive. Plug in a 12, that's positive. Positive times a positive gives me a positive. So this means I can now actually use my sign chart, and I'm going to use my sign chart, question number 6, right? I'm going to use my sign chart and see if we can figure out what the answer is. So now that you're looking at this, now you can see where it's positive and negative. And remember, the whole deal was we wanted this to be less than or equal to 0. Well, looking at your sign chart, where are we less than or equal to 0? Go ahead and make some notes on that on question number 6, and then hit play when you're ready to check your work. So what this means for us, coming on down. So what this means for us, since I wanted it to be less than or equal to 0, I'm going to look for where my negative is. And we had a big fat negative between 5 and 10. So this tells me that my solutions are between 5 and 10. And because it said equal to was fine as well, I'm going to include 5 and 10 in my answer. So yeah, your sign table can help you very easily figure out where your solutions are. So what you're going to do is you are going to have to factor things. Well, you're going to have to set it equal to 0. You're going to have to make sure it's 0 on one side. Move everybody over so that it's 0 on one side. You're going to then factor it. And then you're going to use the solutions you would get if it were equal to 0. And then do the positive negative trick. Make a little number line. Do the positive negative trick on your sign chart to figure out where you should be looking. I feel like we need to practice this a little bit more. Would you agree we need to practice this just a little bit more? I think we should practice this a little more. Let's go over to question number 7. Here I have another sign chart for you. I've changed it up. It's a little different this time. Here I have x minus 4 times x plus 2, and it's greater than 0. So what's going to go in these two little spots? Remember the zeros, put in these two little spots and zeros, all that good stuff. And then pick numbers to plug in between each interval. On each interval, Plug in your numbers to see if you can figure out where you're positive and where you're negative. So go ahead and hit pause, work your way through the sign chart, and then hit play when you're ready to check your work. All right. I can see, I don't think I have a pen over here. I don't have a pen over here. That is very sad. I want a pen. No pen. Boo. I can see that I have zeros at 4 and at -2. If I plug a 4 in here, that would make that 0. If I plug a -2 in there, that would make it 0. We always go least to greatest. So I'm actually going to have to put the -2 in there first, and then I'll put the 4 in there. There we go. All right, so -2 and 4. Oh, those are my zeros, right? So I'm going to put zeros there because that's where it would equal 0. Yay. All right, let's start going. If I pick a number less than -2, so say like a -3. If I plug in a -3 here, ooh, that's definitely negative. If I plug a -3 in here, that's also going to be a negative. Negative times a negative will make that a positive. For this little guy here, something between -2 and 4. So I'm going to pick something easy like 0. If I plug in a 0, that's still going to be negative. If I plug in a 0 here, that's going to be a positive now. Negative times a positive gives me a negative. And now I'm going to pick something bigger than 4, like 5. If I plug in a 5, that's positive. If I plug in a 5 here, that's also positive. Positive times a positive gives me a positive answer. So, I'll double check. Yay, good job. All right, now that you have your lovely little sign chart, now that you know positive, negative, positive, your zeros, you've got everything, I would like you to now use the bottom part of the sign chart to help you answer the question, to help you solve this inequality, x minus 4 times x plus 2. When is that going to be greater than 0? So for question number 8, go ahead and jot down which intervals, and there are 2 of them, are you going to be greater than 0? Go ahead and hit pause to work that, to make note of that, and then hit play when you're ready to check your work. All right, let's see here. It looks like when x is less than -2, so if it's greater than 0, that means I'm looking for where it's positive. And it looks like my function is positive when it's less than -2. And then my function is also positive when x is greater than 4. Yeah, so I wrote that down. Yay! So when x is less than -2 or when x is greater than 4, that's when I have found a solution to this whole thing being greater than 0. If you wrote interval notation, that would be okay as well. So you could have told me -infinity to -2, make sure it's open. Or you could have given me 4 to infinity, again, open on both sides because there's no squashed equal sign there. So now that you're getting the feel for the sign chart and how it all works, I've got one more for you to work out. Question number 9. I would like you to go ahead and solve this inequality using analytic techniques. We've already set it to 0 for you, so you're good to go. You're going to want to factor it, find your zeros, draw a number line, make your sign chart. You got this. Go ahead and hit pause to work your way through it, and then hit play when you're ready to check your work. All right, it was already set equal to 0, or it was always set to 0 on one side, so that makes it easier. So I went ahead and factored this. What times what would give me a 10? That would add up to a -7. And I was like, oh, -2 and -5 would do that. So if I have x minus 5 and x minus 2, that means my zeros are at 5 and 2. I have to start with 2 because, of course, we go least to greatest. So I went from 2 to 5. And then I started plugging things in. So something less than 2 would be 0. If I plug in a 0, negative. If I plug in a 0, that's negative. Negative times a negative gives me a positive. If you plug in a 2, that's a 0. That's why we picked it. And then we'll pick something between 2 and 5, like 4. If I plug in a 4, that's still negative. Plug in a 4, that's now positive. Negative times a positive gives me a negative answer. And last but not least, something greater than 5, like 6. If I plug in a 6, that'll be positive, and that will also be positive. Positive times a positive gives me a positive answer. This particular problem was asking you, so now that you have your lovely sign chart, this particular problem was asking you, hey, when is this less than or equal to 0? Well, I know it's equal to 0 at 2 and 5, and it looks like it's less than or negative between 2 and 5. So that means, ooh, they didn't write it down very well. That means that I would say my solutions are, and I wish they'd written it down, and I wish my little pen worked right now, but it's not working. So that means, do I have my pen here? Are my drawing tools up there? No. Figures. So that means that I've got 2 is less than or equal to x is less than or equal to 5. Again, you totally could have written it as on interval notation. You could have done closed bracket at 2 to 5, also with the closed bracket. You could double check by doing a graph. Number 9 does say to verify graphically. You could have bust out Desmos and double check it. Here's my parabola. Here's 0. And it looks like I'm below 0 from 2 to 5. Yay. So question number 10, just to sum up, bring it all together. So when we're solving these inequalities analytically, we want to make sure that we have a 0 on one side of our inequality. That's the first step. You want to find the zeros of the quadratic function. I do recommend trying to factor. Occasionally things won't factor and you will have to use the quadratic formula. But generally speaking, if you factor, it'll work out okay. Then once I have the zeros, that allows us to make a number line to kind of subdivide things up into little subintervals. And then we do our sign chart and we analyze the sign of the quadratic function within each interval. See if it's going to be positive or negative to try to figure out what's going to make our inequality true. Just like always, as great as the analytic solutions are, it may not always be the best. It's always good to try different types. We like using graphicals. So hey, you've got Desmos on your computers, you want to check your work, graphing it is not a bad way to go. Some people like to make tables. They're really comfortable with tables, and that's okay. And of course, there's always this analytic method with our sign chart. So you just got to keep practicing these different methods, get used to them, figure out what you're most comfortable with. As always, guys, I hope you found this helpful and I hope you found this useful. If you've got questions or concerns, please feel free to email me or come see me after school Tuesdays and Thursdays. You know I'll be around and I'll see you soon. Bye.